making measurements is an important part of science. Remember, chemistry is the study of matter and how things change, matter and its changes, and we might want to make some measurements so we can tell how things are changing and how things have changed, so we can understand what's going on. But as with lots of other things, there is a correct way to make a measurement and an incorrect way to make a measurement, more than one incorrect way. We're going to talk about making correct measurements. This video is going to end up being in two parts. You're watching part one right now. Here's our little triangle that sort of sums up what we're trying to do in chemistry. We're talking about the things that we can look at or observe in the lab or the real world. In chemistry, we try to relate that to what's happening to very tiny particles within matter, atoms, and molecules. And then we also want to learn about how scientists, how chemists write things down, what kind of symbols they use, what kinds of formulas they use to sum things up, how they write down numbers. In today's lesson, which is about making correct measurements, we're going to relate our measurements, which is part of the macroscopic part of chemistry, to how we write them down correctly. How can we get the correct information and put it in the correct form? What's a measurement? A measurement, the definition of a measurement is a pretty simple thing, and here it is right here. A measurement is just a number and a unit of measure. Or you might say it's a number and some kind of label. So here are some examples. 425 milliliters, that's a measure of volume. We've got a number and a unit of measure. There's a measure of mass. Again, the number in blue, the unit of measure in red. There's a measure of temperature. There's a measure of length. Those are all examples of measurements simply because they have a number and a unit of measure. Here are a couple of others that might be a little more surprising to you. If we count something, that's a way of measuring things. So if we're in a room, we count the number of people. There are 22 people. It's a number and a label. That's a measurement. Same way with this measurement of the number of books that someone counted. In our chemistry classes, we're going to make some measurements, and mostly we're going to measure the following things. We're going to measure volume, which is how much space something takes up. Sometimes we're going to be measuring the mass of an object. And sometimes we're going to be measuring length. Sometimes we're going to be measuring temperature. Now, we might measure some other things, and we'll certainly read about other measurements or hear about other measurements. But these are the main things we're going to be doing, and that's what we're going to talk about in our video, how we're going to do these things correctly. All right, let's think about volume first. So volume is often measured with a piece of equipment like a graduated cylinder or a burette. And when we measure it, we're measuring it in liters. Volume is the amount of space that something takes up. We're measuring it in liters. Liters is a unit of the metric system or the SI system. That's what we use for the most part in science class. So we'll measure in liters or things that are related to meters, like milliliters or deciliters. When we measure mass, we'll mostly do it again in metric units in a science class. Usually that'll mean grams or things that are related to grams, kilograms or milligrams. So measuring mass, we measure mass in the same way that we measure weight. For our purposes in this class, mass and weight are going to be the same thing. We're not going to worry too much about the technical difference between those things. When we measure mass, we'll do it in grams. Length. We're used to, in our everyday life, measuring length in miles and feet and inches. But in science class, the metric system, we're going to measure in meters and things that are related to meters, like kilometers, centimeters, millimeters. Temperature. In our everyday life, we talk about degrees Fahrenheit. Here in chemistry class, it's going to be degrees Celsius. And there are times when we're going to have to convert that degrees Celsius to a temperature scale called Kelvin. We'll hear more about that later in the year. Volume, mass, length, and temperature are the four main types of measurements that we're going to be doing in chemistry class. There may be some other things, but these are the ones we're going to focus on today. All right, how do we do it? So here's one sentence that sums up how to make a correct measurement with almost any piece of measuring equipment. When we make a correct measurement, we use the marks on the measuring equipment. That's not too surprising. And then we estimate one more digit. And that might be the part that is new to us. And that might be something that we're going to have to practice. So to make a correct measurement, use the marks on your measuring device and then estimate one more digit. Okay? Using the marks, that part's easy, but what's the deal with the estimation? Why do we want to do that? And there are a couple of reasons why we want to do that. First of all, we want to get as much information as we possibly can from whatever measuring device we're using. So we don't want to round the number off too much. So we can use the marks and estimate another digit to get the right amount of information. But we don't want to report information that isn't there. So we can't go any farther than using the marks and one more estimated digit. So we want to get as much information as possible, but we want to be sure that we don't put in information that really isn't true based on what we see from our measuring device. So doing it in this way helps us get the right amount of information and to use whatever we're using to measure, to get the correct information. All right, let's talk about how we're going to measure volume. Here's an example of a graduated cylinder. We'll see other graduated cylinders during the course of the year. And these drawings on this page here are drawings of parts of graduated cylinders. Oftentimes when we measure volume, it will be the volume of a liquid, and we're going to use a graduated cylinder. Now, in these pictures here, you see part of a graduated cylinder. Here's part of a different one. Here's part of another one here. And each one of these things has a line that shows the top of the liquid that's supposedly in these graduated cylinders. And you probably have noticed by this time in the science classes that you have taken that many liquids, and water is a prime example, many liquids, when they're in a tall, thin device like a graduated cylinder, don't have a flat surface at the top of the column of liquid. They have a curved surface. And that curved surface is called the meniscus. Here's the word right here, the meniscus. When we make a measurement of a liquid that has a curve at the top, we want to make the measurement at the bottom of the meniscus. So in each one of these cases, we're going to look at the bottom of the meniscus. Okay, let's look at graduated cylinder A. So graduated cylinder A has some liquid in it, and we can clearly see that the measurement of the liquid, the volume of the liquid, is between 10 and 20. Most of our graduated cylinders are in milliliters. The numbers on them are in milliliters, and that's the case with these graduated cylinders here. So we're making our measurements in milliliters. So the measurement is more than 10, but less than 20. And there are some other marks. There's not just a 10 and 20 mark, but there's some other marks in between. And if we count them up and figure how many steps there are between 10 and 20, we can tell that each one of these marks stands for one more milliliter. So this measurement is between 16 and 17 milliliters. But we can clearly see from looking at this particular graduated cylinder that there is not exactly 16 milliliters of water in it, and there is also not exactly 17 milliliters of water, or whatever liquid it is. And so we want to estimate one more digit to tell people who are reading our measurement that there's not exactly 16 and there's not exactly 17. So we're not going to write down 16 and we're not going to write down 17. We're going to write down 16 with an estimated number in the tenths place. And my estimation is that the bottom of this meniscus is just slightly closer to the 17 mark than it is to the 16 mark. And so my estimation of this reading is that there are 16.6 milliliters of liquid in this graduated cylinder A. Okay, so I've used the marks, there's at least 16, and then I've estimated how much more than 16 milliliters there is in there. So this is the correct measurement. Now, this is an estimated number. You might look at that and say 16.5. Someone else might look at it and say 16.7. That last number is an estimated number. But that is a correct use of this particular graduated cylinder. Let's try graduated cylinder B. It's got some liquid in it. Again, we're working in milliliters. These numbers are in milliliters. It's more than 3 milliliters, less than 4. Each mark here is 1/10 of a milliliter. So there is more than 3.5, 3.6. It looks like there's exactly 3.8 milliliters of liquid in this graduated cylinder. But if I write down this number, 3.8 milliliters, that is not the correct measurement. Because if I write down 3.8, I'm not telling someone who looks at this measurement if there's slightly more than 3.8 or slightly less than 3.8. I'm estimating that there's exactly 3.8 milliliters, and I write that down by putting in an estimated digit beyond the marks. So the correct measurement from this graduated cylinder here is 3.80 milliliters. The estimated 0 tells a reader that there's exactly, or that I think the bottom of the meniscus is right on the 3.8 mark. Let's try one more time. Let's try graduated cylinder C. 6 milliliters, 8 milliliters. If we count up these marks in here, we can figure out that each mark stands for 0.2 milliliters. So we're going to find out that the bottom of this meniscus is between 7.4 and 7.6, but it's clearly not 7.4 milliliters, and it's not 7.6 milliliters. It's somewhere in between. In my estimation, it's halfway in between. So I'm going to say that this is 7.50 milliliters, and the 0 is because the marks tell us about the numbers that come in the tenths place. We also want a number in the hundredths place. We use the marks and estimate one more digit. So for this graduated cylinder, we're saying 7.50 milliliters. So we've used the marks on our graduated cylinder drawings, then we have estimated one more digit in order to correctly make a measurement using these graduated cylinders. We're going to take a break right now. It's the end of part 1. I'd like to be able to say that you can go to the snack bar and get a soda or some popcorn, but unfortunately that's not the case. But feel free to take a break on your own and come back to part 2 later on.